Okay, so I'll welcome you in French first, and then I'll pass it over to you. Bienvenue au séminaire en informatique cognitive, ici à Montréal. Et notre conférencier vient de l'Université de Californie. Ici. C'est Trott, au département de sciences cognitives. Il va nous parler des défis épistémologiques de l'étude de la théorie de l'esprit, ce qui n'est pas tout à fait la même chose en français qu'en anglais. Theory of mind, ça veut dire la lecture de l'esprit. Les inférences qu'on fait concernant ce que pense autrui. Chez les LLM, les grands modèles de langage, ainsi que les humains. Je ne vais pas résumer encore la conférence de Trott. I'll just finish it with welcome you and looking forward to what you have to say to us about the different mind reading people do on LLMs and on human beings. Trott, University of California in San Diego.
Great. Thank you so much for the introduction and for having me to speak today. So I'm going to be talking about epistemological challenges in the study of theory of mind and LLMs in humans. And so just to give you all some context into the perspective I bring to my own research, I think of my research as sitting at the intersection of cognitive science and what I call LLM-ology. So I like to use large language models as model.
Sean, there's a request that you speak closer to your microphone because they're having trouble hearing you here. Just say question. I think it's all right for the remote audience, but it's not loud enough for the local.
Oh, got it. Should I wait for a second to start again?
No, you don't have to start again. It's just we just want to. That's probably the best we can do. Stay as close as you can to your mic is all I can say.
Okay.
Go ahead. Yours, I'm hiding. Go ahead.
Should I continue just to
Yes,
check?
please. Can you hear me?
Yeah, I can hear you. Okay, great. So as I was saying, I use large language models as model organisms to operationalize theories and test questions that are hard or unethical to test in humans. And I also use large language models as objects of study in their own right. So I deploy the theories and methods of cognitive science to inform what we understand about these black box systems, large language models. And I broadly call this domain or discipline LLM-ology. And all of this work sits atop a set of common assumptions and constraints that I think of as the epistemological foundations, both of the study of cognition and particularly the use of LLMs as model organisms to study human cognition, and then also the use of cognitive science tools to study LLMs. And so in the latter half of my talk today, I'll be talking a lot about what I've been thinking about in terms of these epistemological challenges, particularly in the context of studying something as challenging and difficult like theory of mind. So just to start off, people often ascribe mental states to other people and even inanimate objects. Some of you might be familiar with this famous animation where watching these two-dimensional shapes moving about on the screen, you start to concoct a story, a narrative about how they interact, some sort of history perhaps. And we reason about these mental states, even when they're different from our own. And we make predictions about what people will do in different contexts using that information. Broadly, this capacity is called theory of mind, sometimes called mind reading or mentalizing. And although there's quite a bit of dispute, some of which we'll talk about exactly what falls under this category of theory of mind, whether it's a single unitary construct or lots of different things that we all kind of bundle together into the same term. Nonetheless, this ability to reason about the mental states of others does seem central to social cognition and also understanding and using language. So naturally, there's a lot of interest in where this capacity comes from. And as is often the case, there are a few different competing perspectives. One takes the point of view of an innate and evolved biological endowment. There are both theoretical reasons, but also some empirical reasons to think this could be true. Theoretically, it makes sense that it would have been adaptive at some point in our evolutionary history as social species for us to be able to reason about the mental states of others. The other point of view is that it's assembled out of some kind of experience, whatever that experience might be. And one particular hypothesis in that experiential view is what I call the language exposure hypothesis, which is the idea that exposure to human language augments or constructs wholesale the ability to reason about the mental states of others. Now, this is a hypothesis. There is some empirical evidence consistent with the idea. So, children start to learn mental state verbs like know or believe at roughly similar times as they start to pass tests that are usually used to assess theory of mind. There's also some evidence that training people to get better at sentential complement syntax, things like Mary said that Fred went to the movies, can actually scaffold their performance on these representational theory of mind tasks, where you have to embed mental states of characters, like John believes that Sheila thinks that X, and so on. Most of this evidence, although not all of it, is correlational. And so it raises the question of whether there's actually a causal role for language here, right? Because you could imagine two different directions of causation. It could be that children start developing what we think of as theory of mind because they're learning these mental state verbs, but it could also be that developing theory of mind is what allows them to understand and use mental state verbs. So it's really hard to isolate the effect of language exposure. Naturally, human children are embodied. They have some evolved brain. They have lots of social interaction. It's really hard to isolate the specific thing that you might be interested in, which is the amount and type of language they're exposed to. So ideally, you'd have some kind of model organism, which you can use to expose only to language and test the limits and boundaries of what kinds of behaviors you might expect to emerge only from exposure to language. So this brings me to large language models, or LLMs. An LLM is a neural network with many parameters trained on text data, typically using a next or masked token prediction paradigm. So we're not going to talk a lot about the details, the internal details of LLMs today, but I mainly want to emphasize how they're trained. So we can think of them as a large gray box, this LLM, and that gray box gets fed a sentence like, I like my coffee with cream and blank, and the model is asked to make a prediction about the most likely next word. And when the model is first initialized, it makes very bad predictions. And after observing lots and lots of sentences like this one, it hopefully gets better at predicting that a word like sugar is more likely to occur than a word like salt. And both of those words are probably more likely than a word like dog. Now, this happens over lots and lots of training. These models observe orders of magnitude more words than human children observe. And that's something else that might be interesting to talk about at some point. But nonetheless, eventually they get really good at forming representations that allow them to make pretty accurate predictions about the word that's most likely to come next. And to some extent, these predictions end up mirroring things like human reading time, other kinds of human behavioral responses, and so on. So when I talk about using an LLM as a model organism, I want to emphasize that, a model is not the thing itself, right? We make all sorts of simplifying assumptions when we are using a model organism, whether it's a fruit fly or a rodent, or in this case, an LLM, to ask questions that would be difficult or just unethical to test in humans. But one of the things that's nice about what I'll think of as these pure LLMs, so an LLM trained only on text, that's in some ways a limitation of the model, but from the point of view of testing a scientific theory, it's actually kind of a helpful affordance because they don't come pre-wired with knowledge, they don't have grounded experience in the world, and that means that we can test them specifically as operationalizations of this distributional hypothesis. That makes them really useful operationalizations of this hypothesis about what we know and how much of what we know can be learned from the distributional statistics of language. So how far can we get through distributional statistics alone, coupled with the next token prediction mechanism? And an auxiliary benefit that I want to mention here is that this also informs our understanding of the capacities and limitations of LLMs as well. So the first thing I want to talk about is this 2023 paper, which I worked on with a few co-authors, Cameron Jones, Tyler Chang, James Michaelov, and Ben Bergen. And this is called Do Large Language Models Know What Humans Know? And we adapted a classic method called the false belief task to test whether a participant tracks another person's beliefs about the location of an object. So this is called the false belief task. Many of you have probably come across this. The basic setup is that there are two characters, let's say Sally and Anne. Sally puts her ball in the basket and goes away. While Sally is away, Anne moves the ball to her box, and then we can ask, where will Sally look for her ball? Now, if the participant is egocentric, that is, they're only tracking their beliefs about the ball's location, they might predict that Sally will look in the new or true location of the object, so that is in the box. But if the participant is tracking Sally's beliefs, they'll hopefully predict that Sally will look in the original or false location of the object. Now, upfront, I just want to note that there is lots of very valid criticism of the false belief task as a way of assessing theory of mind, and I'll talk a little bit later about some of the other tasks that we've developed as well. But it's also still pretty widely used both to assess children. Various adaptations have been created to try to test something like theory of mind in non-human animals. So it seems like a good starting point for also assessing the ability to reason about or make predictions about behaviors on the basis of mental states. And one of the benefits of the false belief task is that it really does seem to get at one of the core things we think of as theory of mind, which is representing, maintaining information about mental states of others, especially when those mental states are different from our own mental states. So
I have a question, Trott.
Oh, sure. Yeah, go ahead.
You use representing. What do you mean by representing? Do you just mean encoding somehow?
Yeah, I just mean encoding somehow.
Okay.
Yeah. For now, I think that's a reasonable gloss. Okay, so to adapt this for LLMs, right? LLMs are text-based. We can't give them a video or something like that. So we created 12 passages with a pretty similar structure. The main character in each passage places an object in a start location. It's moved to some end location with or without that character's knowledge. We then probe that character's knowledge state about the object, either explicitly, so X thinks that blank, or implicitly, X looks in the blank. So this will probably be clearest with an example. Sean is reading a book. When he is done, he puts the book in the box and picks up a sweater from the basket. Then Anna comes into the room. In the true belief condition, Sean watches Anna move the book from the box to the basket. Sean leaves to get something to eat in the kitchen. In the false belief condition, Sean leaves to get something to eat in the kitchen, and while he's away, Anna moves the book from the box to the basket. So roughly the same set of events happen, it's just that they happen in a different order. So one of the characters is either there or not there when the object gets moved. Now, in both cases, Sean comes back into the room, wants to read more of his book. In the explicit condition, we ask Sean thinks the book is in the blank and ask the model to make a prediction about the next word. In the implicit condition, it's more of the classic false belief task where we ask where Sean will look for the book. So Sean looks for the book in the blank. We had 16 versions of each scenario because we had 4 different manipulations. So we manipulated whether the character knew or didn't know that the object was moved. We manipulated how we probed their knowledge state. And then we also controlled for a few different things, or counterbalanced it rather across cases. So that included which location was mentioned first, the start or the end location, and which location was mentioned more recently. We also balanced the number of times each location was mentioned to try to get rid of any biases the models might have towards responding to the first or start location. We then presented the entire passage to GPT-3, and we then compared the probability of completing the passage with the start versus the end token. So to illustrate what this means, you could imagine 2 different ways of completing that final sentence. Sean looks for the book in the box versus Sean looks for the book in the basket. These correspond to looking in the start versus the end location, respectively. When we ran the study, this was back in 2022, we were able to extract what's called the log probabilities, or the probabilities assigned to these tokens by GPT-3, which is a closed source model built by OpenAI. And we could then get the log odds of those probabilities. So the log odds basically compares the probability assigned to the start and the end location. And because it's the log of that ratio, if it's a positive value, that basically indicates the model assigned a higher probability to the start location, the token corresponding to the start location. And if it's a negative value, it means the model assigned a higher probability to the end location. So this gives us a somewhat interpretable metric. And we can ask, sorry, was there a question?
No, go ahead.
Oh, sorry, thought I heard something. So we can then ask, how does this metric, log odds, vary as a function of knowledge state? So I'll just go ahead and show you the figure. On the x-axis, you see GPT-3's log odds. Moving to the right means that a higher probability was assigned to the start location. Moving to the left means that a higher probability was assigned to the end location. One thing you might notice is that there's a pretty clear main effect of knowledge Q, so how we probed the model's knowledge of the character's knowledge, so implicit or explicit. And there's some interesting nuances there that I'm happy to talk about if people are interested. The main thing I want to draw your attention to here is that there is a pretty consistent difference between the blue and the red distribution. That is, the blue distribution here represents true belief conditions, and the red represents false belief conditions. So what I mean is consistently, the model is assigning a higher probability to the start location relatively than it does in the true belief condition for that same scenario, that same passage. One way to think about this is if we convert this into an accuracy measure, that is, how often does the model respond in a way consistent with the character's knowledge state, it gets about a 74% accuracy. So it's above chance, definitely far from ceiling, but what we want to know next, right, is how humans do in these passages, because these are entirely new scenarios. We created new scenarios to avoid the problem of data contamination, making sure that the model hadn't ever been exposed to these stimuli. They're entirely new stimuli. But that means that we don't know exactly how people would do on this task. So we recruited over 1,000 participants from Amazon Mechanical Turk. We needed a lot of participants because we wanted it to be a single trial experiment, because we didn't want people to kind of learn what the experiment was about throughout the experiment. We wanted it to be as close as possible to essentially what we were asking GPT-3 to do. So each participant read the passage, and then they weren't told what they'd have to do about the passage, like track mental states and so on. And then on a new page, they're asked to complete the same critical sentence that GPT-3 assigned probabilities to the end token for. We excluded participants who failed various attention checks. There were actually quite a few that failed these attention checks. One thing to note here is that basically the exclusion rate is going to determine to some extent the human baseline performance. So if you include those people, the human average goes way down. That didn't seem like a very fair estimate of the human performance on this task, because it would include all sorts of people who presumably weren't reading the passage very carefully. So we can look at the relative probability assigned to the start location across conditions by humans versus GPT-3 on average. And we see that both of them, again, as we saw already with GPT-3, show sensitivity to knowledge state. So a higher probability is assigned to the start location. That is, it's more likely that a person is going to look where the object originally was if they don't know that it was moved. That's pretty straightforward. In both systems, GPT-3 and the human population are behaving in that way. But humans show higher accuracy on average than GPT-3. And if you build a regression model predicting what people will do in this experiment, the effective condition, knowledge state, was preserved even when you accounted for the effect of GPT-3's log odds. That is, condition, knowledge state, explained variance in human behavior above and beyond GPT-3's behavior. So to kind of wrap up this first section, GPT-3 displayed sensitivity to a character's knowledge states, but its performance was significantly and substantively lower than humans. So language alone, distributional statistics of language, seem insufficient to account for what people are doing on this task. Now, one key limitation is that GPT-3 is, as I mentioned, a closed source model. It's now deprecated. So what that means is that although in 2022, we could access the log probabilities for those tokens, which is what we needed to do to run this analysis, it would be hard or perhaps impossible to exactly reproduce those analyses. So that raises all sorts of concerns about reproducibility. So we, more recently, this is unpublished work, we set out just to replicate just concretely this result with some open weight models. And I'll just mention that really quickly. So for closed source models, as I said, the training data, also the weights are completely unknown. It's all kind of hidden behind an API. So this raises concerns about reproducibility, data contamination, which is when you are testing the model on data it's already seen before. We created new stimuli, so we weren't super concerned about data contamination, but it's still always something to be concerned about, especially if we wanted to test more recent models like GPT-5. So to address this, we replicated that result that I just mentioned with 55 open weight models from 8 different model families of varying sizes. So the question was basically how many and if any of these models show sensitivity to implied belief states, and if so, which factors about the model predicted their performance. So one of the nice things about shifting away from studying a single closed source model to studying a large sample of models is that we can start to ask about the generalizability of the result. We can say, to what extent is this a relatively robust finding about language models, not just a single language model? And we can also ask which features of language models predict how they do. So what you see here is on the x-axis, the number of parameters in each of the models that we tested, and on the y-axis, their accuracy on the task. And that red line is the human baseline. So we see, first of all, that none of those models attain the human baseline. About 36%, so 20 of them, showed some sensitivity to implied belief states. So that's after correcting for multiple comparisons across all the different 55 models we tested. In general, bigger models were better, and also models that were trained on more tokens did better. The best model that we saw was a model called OLMO2 13B Instruct. So this is an open weight and open data model released by Allen AI. And it's specifically the instruct version of the model, meaning it was fine-tuned and instruction tuned on additional data. That said, even the pre-trained model, so the non-instruction tuned OLMO2 13B model, also did quite well at about 73%, if I remember correctly. The kind of key takeaways here is that on the one hand, the result does seem to be generalizable to some other open weight and in some cases open data models. So that's important to know. It's not just restricted to GPT-3. Some of those models do as well as GPT-3, but none of the models can explain away the human effect. So I would say qualitatively, the conceptual conclusions, theoretical conclusions from that first study are basically the same, which is that distributional statistics are enough to give you some amount of sensitivity, but not sufficient. Right? So about 36% of LLMs tested showed some sensitivity. Bigger models did better. No model reached or surpassed the baseline. So distributional statistics can give you some sensitivity to knowledge states, whether or not we want to call that theory of mind, I'll get to in just a minute, but still not at human level, right? And so this does raise the question, I think, which is at what point, if any, right, we might decide there is no reasonable point to conclude that an LLM has theory of mind, or maybe another way to say that is it enacts behaviors that would be consistent that we think of as theory of mind in humans. So do LLMs have theory of mind? This is kind of the question that drives a lot of contemporary research, studying LLMs using various human tasks of theory of mind. And I think there's a few different interpretive views you could adopt here. Given performance in some measure, like the false belief task, you might say, I subscribe to what I call the duck test view. So if it walks like a duck, quacks like a duck, it's a duck. If the model performs equivalently to humans on a false belief task, and if we would conclude that those humans have theory of mind on the basis of that task, then we should imbue the model with that same construct or capability. Another view is what I call axiomatic rejection. So it could be that, a model does really, really well in these tasks, but maybe we think the model is missing something fundamental or foundational, and that could be whatever you think is important, right? So maybe it's that they don't have an evolved theory of mind module, right, through sort of biological evolution. Maybe it's that they don't exist with bodies in the world and have grounded social interactions. Maybe it's that they lack an understanding of communicative intent, at least sort of when they're first initialized. It could be any of those things or all of them. And one consequence of the axiomatic rejection view is that if you think that this kind of system cannot have theory of mind, but if it performs well on theory of mind tasks, that suggests the tasks are not particularly good measures of theory of mind. It's almost a kind of reductio of the tasks themselves. So neither of these are necessarily particularly appealing for a lot of people. One more appealing view is what I call differential construct validity, which is the idea that maybe the task means different things for LLMs and humans. So it could be that the false belief task is a valid measure of theory of mind in humans, but an invalid or less valid measure of false belief reasoning or theory of mind in LLMs. One of the appeals of this approach is that it allows us to say that we can still keep using the test and think of the test as a valid measure in humans if we want to do that. But we don't have to commit, full sail to saying that LLMs have theory of mind just because they do pretty well on the task. Right? So this raises the question, what would it mean for a test to have differential construct validity? It's one thing to say it means different things, but when and why does it mean different things? So in the remainder of the talk, I'm going to be talking about basically where my perspective is coming from on this question. And this is all unpublished work that's very much in progress, but I'm really interested to hear all of your thoughts on it because, as I said, it's very much a work in progress. So there's one set of perspectives that I think you could bring to bear on this, which is theoretical. And then there's another set of perspectives which are roughly empirical. I'm going to work through these all one by one, but really quickly, the theoretical perspectives are, is it plausible that an LLM system could have theory of mind? And if so, do those tasks have base validity for LLMs? And then empirically, do different tasks show convergent validity? And are the processes and mechanisms producing the behavior we see the right processes and mechanisms? So just to work through these one by one, is theory of mind plausible in LLMs? So at face value, one case against this might be that LLMs are next token predictors, right? That is how they are trained. That is what they're trained to do. You might call them something like a fancy autocomplete. Many of them, moreover, are trained in text alone. If you think that theory of mind requires an understanding of communicative intent, requires a capacity for belief yourself, right? To model the beliefs of others, presumably you might need to have beliefs yourself. Maybe you need to have grounded social interactions. None of those things, arguably, LLMs have out of the box. And there's lots of work arguing that theory of mind, or sorry, LLMs don't have intent or that they don't have beliefs. You can just look at how they're trained to know they don't have sort of grounded experience in the world. Those would all be arguments as to why theory of mind is implausible. Now, the case in favor of it still starts with the observation that LLMs are trained to predict tokens. But learning to predict tokens requires LLM to learn to encode or represent things that aid prediction. And in principle, that could include properties of agents described by text. And variants of this argument have been made at different points in the last few years, ranging from the idea that LLMs are simulators, they take on different characters, or as Shanahan argued, that they perform particular roles prompted by the immediate text content, or as Andreas argued, that they, by learning to model the generative process that gives rise to text, they're kind of reverse engineering that process. That might include, along the way, learning things like a simple model of the agents in the text. Now, this is very different in some ways from what we think of as human theory of mind, and that's why I'm going to call it a theory of mind light, right? I will argue that the in-principle case for a theory of mind light in LLMs is not entirely unreasonable. But again, I want to mention upfront that the putative generative mechanisms that could give rise to this will be different than humans. So it's a different order of operations. The system itself is going to be different. And when I say theory of mind light, what I really mean is the model is learning to attend to things using its attention mechanisms and encode information from the context in such a way that it covaries, that information covaries with mental state properties of the characters in the text in a way that allows the model to make predictions about what those characters will do. The ultimate goal of this for the model, right, in the sense of how the model is trained, is to make predictions about tokens, but it might in fact lead to something like a theory of mind light. But that's just completely a priori question, right? It doesn't say anything about whether the tasks that we use for humans have face validity. So it could be that, an LLM system could have theory of mind light, but that the tasks we use to assess theory of mind in humans don't mean the same thing. Right, so why do we use these theory of mind tasks in humans? Well, we can't directly observe the construct. Theory of mind is a latent, very abstract construct. We have some measure, false belief performance, and we assume that that performance is generated in some sense by the capacity. And because of that, we draw this inference about theory of mind from performance, right? We try to assume something or infer something about the construct. Does this inferential logic hold for LLMs? I think it may not hold to quite the same degree, right? And so one reason is that LLMs observe orders of magnitude more text than humans, and some of that text is going to include examples of the false belief task. And so if we think about the measure, the thing that we're observing, false belief task performance, that could happen because the LLM has something like a theory of mind light, but it could be that it's the generalization we're seeing is actually generalization from really similar examples in the training data. We know because we designed entirely new stimuli that it's not really verbatim data contamination, but it does raise this question of what counts as generalization, right? We know that it's probably not data contamination on this end of the spectrum, but we also have a sense that if an LLM is fine-tuned or trained on a bunch of false belief task examples, and then it does well on an example it hasn't seen that basically follows exactly the same template, that seems somehow much less impressive than what we know humans can do and what we observe in humans. It would be more like if we gave humans a bunch of examples of the false belief task with labeled answers, and then they did pretty well on another example they hadn't seen. So that doesn't quite seem like theory of mind or theory of mind light. It seems more like what you might think of as potentially learning shallow heuristics that would allow you to solve the task. So I'm going to argue that they don't really have the same face validity. I don't think they're necessarily invalid, but I think we should want and demand a higher standard of evidence for drawing inferences about theory of mind in LLMs. So even if we would draw an inference about theory of mind using the false belief task in humans, I think we should want to bring to bear a higher set of or stronger set of empirical evidence. So I think that takes us over to this empirical perspective. And one way to assess this is thinking about the perspective of convergent validity. So convergent validity in psychology and other social sciences is this idea that if different tasks measure the same thing, then behavior on those tasks should correlate. And this is work that I did with Cameron Jones and Ben Bergen. And what we wanted to do was to address this issue that no single task is going to provide sufficient evidence for theory of mind, but maybe we could establish convergent validity across a diverse range of tasks. And so we developed this epitome benchmark experimental protocol inventory for theory of mind evaluation. Really quickly, I'll talk about the 6 tasks that make up epitome. I won't spend a ton of time on this. One of them was just the false belief task, which you already saw. Another is this recursive mind reading or mentalizing task. It's very similar to the false belief task, but it involves more embedded belief states, so up to 6 or 7 levels of embedding in some cases. And this is based on a human study from 2015. We also adapted 2 canonical tests of theory of mind used in humans where a participant reads a story, a short story, and responds to questions about why characters did certain things in that story. So this is a free response task. And then we adopted several pragmatic reasoning tasks, because these are cases where a participant, whether an LLM or a person, has to infer mental state information about a person in a passage and then deploy it to infer what that speaker means by what they say. So there's sort of multiple operations that a person has to do in these cases. So we adapted all these for GPT-3. We also obtained a human baseline for each task. More recently, and I'll talk about this in just a minute, we ran these again on a range of open weight models. So I'll show you first just the data from the original epitome paper from 2024. On the x-axis, you have the different tasks: false belief, recursive mentalizing, the 2 short story tasks, and then the 3 pragmatic reasoning tasks. These are just the different versions of what we call the scalar implicature task. Now, on the 2 sort of tasks that involve just explicitly reasoning about mental states, so false belief and recursive mind reading, GPT-3 was better than chance, but it also fell short of the human baseline. On the 2 tasks that involved free responses, GPT-3 actually attained, or in some cases was better than the human baseline. And then on those pragmatic reasoning tasks, GPT-3 was at or well below chance. Now, there's a couple reasons why it could be so bad at these pragmatic reasoning tasks. Maybe one is that, maybe it's just bad at pragmatics. Based on some other evidence that came around this time, GPT-3 and other models do pretty well in pragmatic reasoning tasks that don't involve explicit mental state reasoning as well. So one of our tentative conclusions was that maybe because those pragmatic tasks require multiple operations like sampling and then deploying mental state information, that made it a bit harder for these models. And that would be an interesting point of limitation or difference from the humans. Now, of course,
Sean, would you mind giving a concrete example or 2 of this last category? Because it's very
right.
abstract for us.
Yeah. No, that's a good question. So for the indirect request task, an example would be you read a passage in which a character and a friend of that character are in a car, and the heater in the car is broken. And the other character, let's say Jonathan, either knows or doesn't know that the heater is broken. And Jonathan says, "It's getting cold in here." And then you're asked to infer whether it's getting cold in here as a request. And what we see in the original human study, so this is actually work that I published with Ben Bergen in 2020, is that people are more likely to interpret that sentence, "It's getting cold in here," as a request if they think that Jonathan, the speaker, doesn't know that the heater is broken. And when Jonathan does know the heater is broken, they think it's less likely to be a request. And there's a bunch of different scenarios kind of like that. Does that help address the...
Thanks.
Great. Yeah, thank you. Thank you for raising it. I think that's
frankly, it wouldn't hurt if you just gave a couple of examples of the middle category too, so we could have it in
Sure. So the short story task, you read a short story by Ernest Hemingway called The End of Something. It's basically about a couple rowing on a lake, and they have an argument. And afterwards, after you read the story, you're asked questions, some of which just probe basic reading comprehension. So the events, like where they were, what they talked about, that allows you to get kind of a baseline, just like how much people attended to the basic events. And then the mental state reasoning questions are things like, why did Nick say to Marjorie, "You know everything"? And then there's a rubric that you can use that were developed by the original authors to try to score these responses. So things like, is Nick just actually thinking that Marjorie knows everything, so not really taking into account very much about the actual motivations, all the way up to Nick is upset with her and he's trying to provoke an argument. So basically a rubric that allows you to try to score different responses in terms of the extent to which they are accurately modeling the emotional and belief states giving rise to the behaviors in the story.
This is the one that you said the LLMs do almost as well as humans.
Yeah, so they actually, right here, I don't know if you can see my cursor, on the short story tasks, GPT-3 did better than humans on average. So there were humans that did better than GPT-3, but the human mean was below GPT-3. There's all sorts of reasons for this. So it could be that people were just unmotivated, right? That's always a challenge. This task, both these tasks in the middle were free response tasks. So, when you're asking people to generate text, you're always going to run up against the problem of maybe they just don't feel like filling out the survey or responding to those questions. We do have a reading comprehension baseline. So even when we filtered for people that scored basically a perfect score on the reading comprehension portion of the test, GPT-3's performance was still a bit higher than the average human performance. So that seems like not the only thing, although there was still a difference in how long GPT-3's answers were versus the human answers. So there are various limitations, I would say, to this kind of result, but I do think it's notable that, yeah, GPT-3 does pretty well. And yeah, the human average is significantly lower in this case. The strange stories task, both humans and GPT-3 do quite well. The human average was numerically slightly higher, but not significantly higher. Okay, so this is a bunch of different tasks that we developed to try to get at this question of convergent validity. One of the limitations of using just GPT-3 here is that you can't actually really assess something like convergent validity because you have an N of one model, GPT-3, in each task. So what we did was we reran recently these tasks, except the free response questions. And I can talk a little bit about why, but the brief version is that they require a lot more coding. We're thinking about extending it to include those questions, particularly because GPT-3 did well on them. But we wanted to look at some of those other tasks first as well that are easier to analyze more quickly for all these different models. So we look at 36 different open weight models from 3 model families. We also added several attention check questions, which basically probed how well the model was attending and encoding basic information about those false belief stimuli. We then also added a new false belief task using the stimuli from the indirect request task I mentioned. And I'm happy to give more details about any of those things. I'll talk more about the intention checks in just a minute. First, I want to ask whether any of the open weight models outperformed GPT-3 or humans, and whether any of those tasks exhibited convergent validity with each other. So to start out, I'm just going to show you the 5 tasks that we also have GPT-3 and human data for. So these are the pragmatic reasoning tasks on the left, so scalar implicature, indirect request in the middle, and then the false belief task and the recursive mentalizing task. The white circle in the middle or the clear circle in the middle with the error bars is the mean of that sample of LLMs, which arguably doesn't mean a whole lot because the LLMs range a lot in performance and in size, but each individual point also shows each individual LLM that we tested. And now we can superimpose GPT-3, that red diamond, and then the human performance, which are those gray solid circles with those error bars. And so there's a couple conclusions to draw here. One is that on average, the LLMs in the sample was generally below or on par with GPT-3, pretty much always below humans. Select models outperformed GPT-3, but also humans in specific tasks, so like the indirect request task. So that was the first time we'd actually observed that. A model, this model Quen 2.5, actually outperformed the human average on this indirect request task. Now, it's one thing to say, this model outperformed humans on this one task. That's not quite what we are ultimately interested in with Epitome. We want to know to what extent these tasks correlate with each other. So we built a big correlation matrix looking at how whether models that do better on one task also tend to do better on other tasks, specifically for the theory of mind task. And what we see is that there is some correlation between these tasks. So in general, doing well on the false belief task means that you do a little bit better on the recursive mentalizing task, a little better on the modified version of the false belief task, and so on. But it was actually negatively correlated with performance on the indirect request task, negatively correlated with performance on the first scalar implicature task. And one way to kind of concretize this is that if you look at the average correlation across all the pairs of theory of mind tasks we looked at, so excluding those attention checks, we see that the average correlation is 0.08, so very, very low. Whereas the average correlation between the different attention checks, so basically the basic encoding of information in the passage, was more like 0.2. So not really, really high, but much higher than the theory of mind correlation. So I would say, in answer to the question about convergent validity, there's some correlation, but it's not particularly robust. And I wouldn't point to this as evidence that the models have theory of mind, right? I don't think if the question here is, do they have convergent validity? I would say at best a little bit and not much, right? So not much here. And then the final question I want to ask is, are the underlying processes and mechanisms giving rise to their behavior the right ones? So one way to think about this is if the false belief task actually reflects theory of mind or theory of mind light, LLMs should display the right precondition. So I've been thinking of this as precondition validity. And in this case, you might imagine that representing or encoding somehow the belief states of characters in a passage, it seems like that would benefit from a basic situation model. Maybe you don't have to know where the items are yourself to represent where a person thinks the items are, but it sure seems like it would help. It seems less plausible that a model's using something like theory of mind or theory of mind light if it's not even able to represent those basic preconditions. So that might include things like where the item was originally, who put the item there. So let's say Cameron put the book in the box, where the item ended up, maybe it ends up in the bag, and who moved it, maybe Pam moved it there, right? So we have these 4 attention checks. These are the different attention checks that we asked about each of those false belief passages. And we can ask 2 questions. One is, are models at least as good as the attention checks, right? If these are preconditions to doing well on the false belief task, models should be at least as good or better on these than they are on the false belief task. So that's kind of a validity check in some sense. And does doing better on these ones predict that you'll do better on the false belief task? So I'll show you here each of the 4 attention checks. And on the x-axis, you see the attention check accuracy for that question for a particular model. So each individual point here is one of the open weight models. On the y-axis, we see that model's false belief task accuracy. So there's a few things to observe here. In answer to that first question about whether the models are at least as good as the attention checks, we see that for questions about where the item started out, they mostly are better. So for questions about the item location, particularly where the item started out, and to some extent where the item ended up, models are better at reporting that information than they are at reporting where a character thinks the item is going to be. That is, they are better at these preconditions than they are at the false belief test. So that's sort of a positive response or a good finding in terms of thinking that the model has the right preconditions. Performance was much more mixed for questions about agent actions. So specifically, questions about who the original character was. So who put the book in the box? In this case, the answer would have been Cameron. Cameron and Pam are the 2 collaborators on this project. So who put the book in the box? The models are actually really bad at this. And in fact, many of the models are much worse at this than they are in the false belief task itself. So if we think of this as a precondition, then they don't meet that precondition. So the fact that they do better on the false belief task than this precondition task is a little bit concerning. They, in general, do better on the questions about the second person, right? So who moved the book from the box to the basket? That was Pam. The models generally do better on that. There's a whole cluster of models that do better on that than the false belief task, but there are some stragglers over there. Also, questions about item location were pretty predictive of false belief task performance. So specifically, knowing or being able to report where the item ended up, that information, that model's ability to do that, can predict false belief task accuracy with an R-squared of 0.42. So it explains about 42% of variance in false belief task performance. That said, model size was a better predictor itself. So bigger models did better. We already found that. That was an R-squared of 0.5. So that's a little bit mixed as well. So we see mixed evidence for a basic situation model. It does seem like the LLMs benefit from accurately modeling item locations, but not the first mover's identity. And then the last question I want to briefly touch on is whether these abilities display an appropriate developmental trajectory. So it might matter not just that at the final step of training, right, these models are better at some of these preconditioned tasks than at the false belief task. That seems important, but it also seems like it should matter whether those develop at an appropriate stages, right? So what's nice is that some of these models, specifically OLMA 213b and some of the other OLMA models, have publicly available pre-training checkpoints. That means that we can assess accuracy on each of these questions, including the false belief task, over the course of development and training. So that gives us a developmental timeline for when these models start to improve. So what I'll show you here is performance on both of the first 2 attention checks as well as the false belief task performance. So in green here, you see performance on the false belief task. In gray, you see performance on that attention check question. So the item was first in the start location, at the end of the story where the item ended up. You see the models literally right out of the box seem to have a bias towards reporting the end location. That eventually goes away, but I just wanted to bring your attention to that in case you had a question about that. What we do see, and this is the important thing, although both of these metrics require quite a bit of training to start improving, the ability to report information about the start location and the end location of an item, that starts to change and improve sooner than the ability to accurately report beliefs about item locations. So in other words, these preconditions do develop, they precede reporting beliefs about item locations. So that's, again, sort of a positive finding in terms of meeting the right developmental conditions. That said, when we turn to some of the other questions, as we saw before, performance was just really bad for reporting the original mover, so it's much worse than the false belief task. The timing doesn't really line up. Reporting the person who moved the object does precede false belief task performance improvements. So again, it's kind of a mixed set of findings. Reporting where an item was and who moved it last precedes and also predicts reporting where someone believes it is, but reporting the original character did not. So moving forward, one of the things we really want to work on, and this is stuff that's very preliminary, is moving from just looking at the model's behavior to starting to look inside the model. So we can start to ask, because we can intervene on these systems, what kinds of circuits and internal mechanisms produce the behaviors we're observing? And we can ask when those circuits start to appear during pre-training. We can ask whether there are consistent circuits that subserve behavior on the false belief task, to what extent those circuits depend on what we might think of as these basic situation model circuits. And that'll hopefully give us a clear picture of whether the model's mechanisms that are producing those behaviors that we observe are indeed the right mechanisms. So I'll just leave with a question mark on this question here. So to wrap up, right, do LLMs have theory of mind? I would argue that this can't be answered definitively just by reasoning a priori about the kinds of systems they are, although that obviously informs how we study them. But I also think that we can't interpret the human tests that we run, like the false belief task, at face value. I think we need to have theoretically motivated empirical investigation, and that includes looking for convergent validity across tasks, which in this case we don't see a lot of, satisfying the preconditions for something like theory of mind light. In this case, we see mixed evidence. At appropriate developmental stages, again, we see some positive evidence, some mixed evidence, and then something we haven't done yet, which is looking into the internal mechanisms of these models. And this is not exhaustive. Of course, there's other things looking at robustness to different manipulations. There's been a lot of great work on that in the false belief task literature. And then the final thing I want to close with is that I've been using this plural, right, LLMs, right, and asking about it as a sort of coherent, cohesive population. But it's not clear that we can actually do that, or that we're licensed to do that on the basis of, any given empirical result. I think another epistemological challenge I haven't really touched on today, but that I've been really interested in recently, is what population are we actually studying when we study a given language model? One of the limitations of the earlier work I've talked about today with just GPT-3 is that it's an N of 1, essentially, and it's unclear whether GPT-3 is representative of language models in general, or what population would even be trying to study when we study language models. Obviously, psychologists of human behavior face some similar questions with unrepresentative human samples from undergraduate university institutions, for example. But I think the situation is even more complicated for LMs because they range in size and training data, and vastly range in performance on different tasks. And so I think what we really should hope for going forward, and what I'm interested in moving towards, is a better theory of generalizability in LLM research. So thank you all for listening. Thank you to my collaborators for working on this work with me, and for lots of other people for fruitful conversations about this, and in general, the growing community of researchers working at the intersection of these fields. And thank you all for listening, and I'm excited to talk about the work and answer any questions you might have.
Okay, first of all, thank you very much for your thought. Well, at this point, usually there's shyness on the part of the audience here and also remote audience. So I'm always there to jump into it, but any time that you're ready to raise your hand and want to ask a question, okay, Josh, you're in there. You preempted me. Go ahead.
It's all right. Oh, sorry. Here, you can see me. Oh, that's terrible. There, no, not that one. Sorry. Good talk. Thank you. I was curious. I'm not super familiar with the false belief task research, but is there any work where you have the object being moved as kind of a natural home, like you have a bottle of milk, or you have a that belongs in the refrigerator, or you have a sweater that belongs in a dresser, and you put the natural home of that object as kind of a foil in the scenario? because I sort of wonder if, maybe not now that they've gotten bigger and arguably more sophisticated, but I wonder if the early LLMs would have fallen down on that and been like, oh, well, milk belongs in the refrigerator, so like that's where it'll be. And milk is maybe a bad example because you could, even with theory of mind, you could assume someone would do that, but like putting a book back on the bookshelf rather than like, in a chest or something.
No, that's a great idea. Yeah, I have the same intuition that possibly even some of the more recent models, but definitely like earlier models would basically that seems like a way to get at whether they would fall prey to a kind of heuristic uh, based on other associations about the object and its sort of normal home. I don't know specific work manipulating that. There is a few different papers that came out recently. So there's a paper from 2023 that manipulates, there's actually a couple papers from this time period. So there's one by Tomer Ullman and there's one by Shapiro et al. That basically manipulate other properties of the situation. So whether the box is transparent, other kinds of things that that if you are a person in the situation should actually affect what the kind of right answer to the question is, because the character could actually see through the box if it's transparent and so on. And both those papers found that the models they tested were not really robust to a lot of those alterations. Another paper that I think just came out this year, which was published by some of my collaborators, including Cameron Jones, tried to take a kind of systematic approach to this, where they try to identify all these different permutations of a stimulus, like whether the box is transparent, all these other things that might affect what the correct answer should be, but keeping the underlying like logic of the passage the same, so the object getting moved. And then they also, I think, modified the verb, so like recognize versus think or believe, and they do see some interesting variation there. I think one question is to sort of look for the human baseline in this as well. I would be curious to see how because there's all this literature on sort of shallow processing in humans as well. So I would want to know roughly how humans perform on some of these tasks. And I believe that paper does have a human baseline, but I might be wrong. But I do think your idea of also manipulating kind of a natural home for the object is an interesting one. Yeah. So short answer is I don't know of work specifically manipulating that, but there is work manipulating other things, and the models don't seem entirely robust to lots of those things. That kind of to me falls under the category of like the situation model type thing. Like, do they actually have a coherent picture that's robust to all these small changes, or do they have all the right preconditions? So that is also something we're interested in looking to.
Yeah, thank you.
Okay, thank you for that. And the next question is ready to come whenever it wants, but I'm ready if there isn't a question to throw in something. I think, Sean, that it's extremely interesting that you're looking at theory of mind, and everybody wonders about it, but it's kind of overreaching, because what's behind, does an LLM have beliefs, period, beliefs about whether others have minds and are thinking of something or know something, is well beyond the more basic question of, does it understand anything at all? So let me pick another domain than theory of mind, but it can stand in for, you could have done the same kind of developmental studies with this if you had been looking not at theory of mind, but simply a theory of space. In other words, where things are, what if you tell somebody something about the position of the thing, can they infer other properties of the thing? There have been some interesting experiments on LLMs lately on geometry, in which they use something you can't do, a rudimentary image processing capacity, to be able to give a geometric design to the LLM,
right,
and then ask it about it, and it says words to you that sound like it knows what it's talking about, and then you ask it something that to anybody with eyeballs is evident if you look at the figure. For example, what is the angle of this particular? How many degrees is this angle? And it says something way off.
right.
Clearly makes it clear that it hasn't got any spatial sense here at all. are there parallels to this kind of thing that we could ask for in the case of theory of mind or vice versa?
Yeah, no, I mean, I think that's a great example. And I actually think that kind of relates to the previous question, if in a way, which is that, I mean, in this case, you're talking about visual representations, and there might be all sorts of different reasons why the model is bad at that. It could be more of a failure of the vision encoder than the what we might think of as like the LLM itself. But and there's lots of research on vision language models and where they might go wrong. But that said, I do fundamentally agree, I think, with the basic thrust of the question, which is that I think in this example, the model just isn't robust to all sorts of different things that seem like they should be obvious to people, if I'm understanding what you're getting at. And I think that is similar to some of the work that's been done in the theory of mind literature with large language models, basically asking to what extent small changes to the scenario produce the right kinds of responses that seem like they should be obvious to people. So I'd mentioned the example of a transparent box before. I think that's maybe a nice example because it really is a very like grounded, uh, embodied thing to be like it's obvious that if you're in a situation and the box is transparent, you can see through the box and see that something is there. You know that if someone else is seeing into the box, they know what's there. That's a case where it should be obvious to us. And it also seems though like it requires some amount of sort of experience with that kind of situation or understanding the things in that situation. I guess I want to emphasize that when I talk about whether it has theory of mind, I really do mean this kind of like theory of mind light. And by that I mean the ability, or the maybe more precisely the behavior of encoding systematically information about the characters in a passage such that the model's activations as it's encoding a scenario or a text stimulus end up covariating with manipulations of mental state properties and allow them to make predictions about those behaviors that are consistent with those mental states. Uh, I think it's totally reasonable to say that's like a pretty different thing than the really broad constellation of abilities we call theory of mind in humans. And as I think I mentioned in the talk, there's not necessarily agreement about whether the false belief task is itself a good measure of theory of mind, even in humans. And there's also disagreement about whether even the construct of theory of mind is like a coherent construct, because even in humans, again, these different measures don't all correlate with each other. But I guess I would say I think of it as fundamentally an empirical question. So just as with the example with the visual example you brought up with the angles, that seems like it is an empirical demonstration of like a limitation of how the model integrates visual information, and it seems to be doing that differently than humans.
Not quite. I mean, it isn't that, because if you did, and I did do this, I took this failing model and I used Steve's here, that's good. And I used prompt engineering on the model to just Socratically elicit from it something that in the end it's got to know.
Right.
And so I did it piece by piece until in the end it gave the right angle. But it was
Right.
all done by words. And so I went back and said, did I demonstrate that it had understood it all along? Or did I demonstrate that it didn't understand a thing, but you can really get far with it if you keep placing the words right. You're looking at distribution, but this is more than distribution. It's actually prompting.
Yeah, no, I mean, that actually relates to something I've been thinking about a bit recently, which is that it's very hard to design a task to assess some capability in a text-based language model, which you're going to have to design the task with linguistic input, linguistic output. If the task is in some sense expressible through language, you could imagine some kind of linguistic shortcut, for lack of a better word, that you could use to solve the task, even if you don't think that's how humans are solving the task. Which, I mean, obviously, there's been lots of philosophical work on exactly this question. Yeah, I don't think there's a great way around that. The best thing I can do is to suggest that we, in taking an empirical approach to it, try to triangulate the construct we think we're trying to get at, like theory of mind, which really is a very abstract and hard to measure construct, and use different tasks, different probing mechanisms that get at all the different theoretical preconditions we think should be present for that task. And that's why, I mean, I would say in answer to the question that I started with, like, do these models have theory of mind light? I don't think that the empirical evidence I brought to bear can give us an affirmative answer to that question right now. Like I don't think that the evidence for the models I tested, and again, as I mentioned, we don't know whether that generalizes to other models, but for the models I tested, I don't think we can say, yes, these models have, or they're very likely to have theory of mind light, because they don't show convergent validity across the task. The evidence for the preconditioned validity is mixed. So, I mean, to me, that kind of seems like, again, maybe I might be misunderstanding, but it seems like kind of what you're mentioning with the lack of ability to respond to specific questions about a visual stimulus. And as you said, it seems likely that we could probably construct scenarios or prompts where the models do respond appropriately, let's say, to who the original person in the passage was, which is something to do really badly on. And maybe that's analogous to you're saying, like, Socratically, you kind of like draw out the right knowledge. And maybe a good way to think of that is like, where is that knowledge located? Is it located in the dialectic, or is it located in the model originally? And you're extracting it from you're just coming up with a better way to extract it from the model. Is that kind of what
That's
you're?
going to become a more and more important theme apart from all of this, right? But what I would say was that, are you fooling yourself when it doesn't succeed with theory of mind full blown? And you say, well, maybe it's theory of mind light. You're already helping yourself to something that may not be true at all, which is that there is no theory of mind going on here at all, light, hard, heavy, or anything. It's just something else, something really different.
Yeah, no, I mean, I think that's always possible. I guess like that seems like it would fall into what I think of as like the axiomatic rejection view, right? Like that if there's something foundational that the model doesn't have that you think is why it can't have theory of mind, whether light or otherwise, then I think, am I right in interpreting it that way?
Well, in my case, you are, but I'm not. There's lots of other people that doubt it for other reasons. And mine is clearly grounding based, and
Right.
without grounding, you can't have any of that stuff for real.
Right.
Uh, but for example, let me give you another example. Steve, by the way, how did your talk go?
Hi, Sean. How are you?
I'm great. Yeah, good to see you.
Nice to see you. Yeah, no, we had a fun time. We're enjoying ourselves, and everyone showed up that enjoyed it. And it was lovely. How'd Sean's talk go? It looks like it had a lot of fun.
It went very well, but we now need to face it head on.
By the way, Stephen, you're completely wrong. Just to put a
Oh, okay, good.
You know, of course it has a theory of mind. My God, that's just no.
It's really good to have Steve Hansen in the audience for you, Sean. Anyway,
well, I'm in Scotland having a lovely time, so I'll sign off. I just wanted to come in and say hi and not steal anything here. So, be bye.
okay.
Cheers.
We're not done yet, Sean. Okay. I keep on trying to get the, yes, go ahead. Wait a second. Let me turn the camera to you. I'm sorry.
Hi, Sean. Thanks for being here today with us. I was wondering, how do you separate in your studies in Epitome genuine belief of reasoning from pattern matching, for example, in LLMs?
Yeah, no, it's a great question, and I that's sort of what I'm gesturing at in that one slide when I talk about. I can actually bring that up really quickly. This question of, is it generalization, or are we measuring essentially a kind of pattern matching? I mean, I don't think that. Again, I guess there's kind of two perspectives here. One is this axiomatic rejection idea that there is something fundamental that the LM doesn't have, whether it be grounding or a world model or something, and therefore it can't be doing what we think of as the generalization or the true theory of mind or belief reasoning. So it kind of by definition has to be kind of pattern matching. I guess I usually think of it in terms of I do think of a lot of cognition as a kind of abstracted pattern matching. And there's obviously debate about the levels of abstraction at play and exactly where those patterns are recognized from and what representations they're transduced into. But I think that the question for me is more are the patterns that the model is attending to, are they the right kinds of information? Do they have the right kind of informational content or representations in them? And the way to assess that, I think, is one way is using convergent validity across these different tasks to see whether there's seems like a similar underlying circuit or mechanism responsible for doing belief reasoning in all sorts of different situations. So just to back up a second, I guess one reason you might think this is a shallow form of pattern matching, not like a sort of deep generalization, is if the model is using like very targeted strategies for very different tasks, even if those tasks are all intended to measure something like theory of mind. So you might think, the model has learned from its training data a really specific strategy to solve the false belief task, which is a different strategy than it uses to solve the short story task, and so on. And so the whole point of the convergent validity approach is to say, if those tasks correlate with each other, then that's one small piece of evidence that the models, the same models that are good at one task are also the models that are good at another task, which doesn't mean that they're doing this, that they're all using theory of mind for this task, but it's, if we didn't find that, that would be better evidence against the models using the same kind of strategy for this task, potentially. We don't see a lot of convergent validity, so that's sort of a point against that. The precondition validity is kind of the other perspective on that, which is basically a way I think of is to try to assess coherence or the cohesiveness of that model's picture. And so again, going back to this pattern matching or belief versus belief reasoning, to me, the kinds of pattern matching we might worry about as not being indicative of belief reasoning is like, again, kind of overfitting to specific features of the task that allow you to kind of game the task, essentially, or use shallow heuristics. And we don't know exactly what those heuristics would be, but you could imagine lots of them. These models are very big and they have lots of parameters that they might be able to use to memorize features of the task that basically confounds that are hard to control for. And so the point of the situation model approach is to try to establish or ask whether the models encode the right other sorts of information that should in principle be necessary for reasoning about belief states. So I guess in answer to your question, I think of it as a set of empirical questions you can ask guided by kind of a theory of what should go into belief reasoning. And so a theory of belief reasoning seems like it should depend on having the right other kinds of information about the passage, maybe having a relatively stable representation of beliefs that's robust to different permutations in the passage and so on. But yeah, I don't know if that kind of addresses your question or.
Yeah, it addresses it. Thank you very much. But from what I understand from what you said, does it have to do with the way we define reasoning?
Does it have to do, sorry, I didn't catch that very last part.
I mean, the reasoning definition, the way we define it, I saw many definitions. For example, in theory of mind,
Right.
we have many dimensions and many kind of definitions through time. And I think you took some of yours to do your studies, but does it apply to all of them?
Yeah, definitely not, right? So you're absolutely right. And I think I mentioned this very briefly, but didn't have a ton of time to touch on it. And even in humans, the literature, there's a lot of debate about what we're actually assessing with a given task. There's going back to 2000, there are arguments that the false belief task is not a good measure of theory of mind. And there's been many, many other tasks developed, and all of them are kind of getting at subtly different things potentially. And there are even arguments in the literature that there isn't a single unitary construct called theory of mind. That's why, I mean, one way to think about, I guess, like the trajectory I've been on is sort of starting out with this false belief task, which is kind of the canonical task, and then trying now to reverse engineer what it is the models are doing to solve this task. And I don't think that even if the models show all the right kind of performance on the situation model, et cetera, that can lead us to a 100% confidence of saying they have theory of mind. At best, I think it can give us a better indication of the strategies they're using to solve this task and to allow us to adjudicate between maybe the less interesting way they might be solving the task, which is kind of maybe using these shallow heuristics, versus the extent to which they are building up a kind of coherent situation model of the passage and using that information to deploy it to predict the behavior of agents in the passage. But whether or not that translates to other either subtly different or really different definitions of theory of mind, especially, you know, there's so much work on theory of mind in its multimodal manifestations, the ways we might attend to facial recognitions, the ways that information gets communicated gesturally. There's all sorts of things that we just are totally outside of the scope of this kind of question. But I think for the things that are inside of scope, so responding to questions about characters in a passage, I think still you kind of just have to take it, in my view, task by task. And so right now we're trying to figure out what it is that the models are doing to solve this false belief task. We don't know whether that will give us a generalizable answer about what they're doing to solve some other theory of mind task. I think that the only way to answer that probably is to develop a similar kind of research strategy for that task, which might be unsatisfying, but I think is probably for me, the thing that I feel like I have to do. But.
Thank you.
Okay, we're getting close to the last call. Is there anybody else here who wants to ask a question locally? Yes, okay. I'll aim it at you.
Hi, Sean. Thank you for your talk. Do you hear me?
Yeah, I can hear you. Yeah, thanks.
So my question is more societal. More and more people are using ChatGPT as a therapist, or at least as a confidant.
Mm-hmm.
And this probably indicates that most of these people recognize a form of empathy in LLMs. So I'm not happy with this because I think we need social interactions. But if we are pragmatic, it's something that happens and become more prevalent. So do you think that research in your field about the theory of mind in LLMs can indirectly cause more harm in the future by pushing even more people towards ChatGPT, for example, or that LLMs with a theory of mind could be able to implement a therapy or a social life, a normal social life?
Yeah, interesting. I mean, there's a few different components to that question. So one, I mean, I also kind of have a pretty mixed feelings, I would say, to say the least, about those use cases of AI or ChatGPT. I mean, the question of whether it's would push people towards using them, I don't view the kinds of stuff I'm doing as actively trying to build systems with theory of mind. And if you view it as an empirical question, I mean, if the answer to this question of whether they have something like a theory of mind light is no, then that's the answer. And to the extent that that influences what people do, then I think it should push them away from it. I don't really think that people are using ChatGPT as a therapist in a way that's contingent to the responses or the answers I get to these research questions. I think that that's a completely different sort of governance issue of how these technologies are regulated. I mean, I guess the extent to which I would view that as kind of a thing to be concerned about is if the research on what the models can and can't do is giving a kind of cover or like legitimacy to these technologies, and maybe that's one thing that you're getting at. Yeah, I mean, I think that's a legitimate concern. I think that if someone was using this research in favor of, you know, an actual sort of policy agenda or applications of technology that seem premature, I think that it is probably in science community's responsibility to speak out against that. I don't think that, like, to the extent they're using the published research as cover for some application that a scientist disagrees with, which I think is always the case in any domain. So far, I mean, I don't think we have. So all of the work that we've published in this area is basically finding pretty mixed evidence, right? We consistently find that the models do not perform as well as humans do on these tasks. So I don't really see how that could be used to justify the idea that they have theory of mind and therefore are like really well suited to being therapists. But let me know if I didn't understand that part of the question.
Maybe it was a naive question, but because if we reach a certain level of maybe a comparison about, because even the construct of theory of mind, I understand that it's something that is not clear even for humans. But Yeah, maybe it's a question with.
It's a more general question. It'll be coming up again. We're getting close to last call, but there is something I wanted to ask you about that I didn't understand. Tell me if I misunderstood this. You said, I don't remember what effect you got or didn't get, which we're saying could possibly be caused by or not caused by the fact that LLMs have the Sally Ann literature as part of their database.
Yeah, yeah, right.
Okay, well, I have an analogy with that, okay? It's for another thing that I know that you're with, or your group is connected with, which is the question of UG in linguistics, namely, to what extent could the performance of LLMs, the error-free performance on UG rules, universal grammar rules, be caused by the fact that they can read the linguistics literature?
So are you asking whether they, if they display sort of the right response, like acceptability judgments or something to?
I'm wondering whether whatever it is that you meant by knowing the literature on Sally Ann also applies to knowing the literature on UG.
I think potential. I mean, unless I think it would depend on exactly how this is being assessed. But yeah, I mean, if the question is what do the models know about grammar, for example, and if you're using that empirical question to assess a question about universal grammar, I think the training data absolutely, like what's in the training data absolutely matters. And it's not inconceivable that a large enough model, which you can kind of like, the more parameters the model has, the more kind of greedy it is to suck up all the information in various ways, and to some extent maybe memorize some of the information. It might be able to learn through that kind of training process, in a way that we don't want it to, the kinds of rules from, directly from a textbook or something like that. I think that's why work in this space has really gravitated towards things like the Baby LM contest. I don't know if you're familiar with that, but using smaller models trained on more roughly developmentally plausible amounts of data, sometimes child-directed speech and so on, in the hope that even if the model trained on 1 trillion tokens understands or can respond correctly to center embedding, maybe the model trained on 90 million tokens can't. And so I think that's another layer on this question, which I think is similar to the point I was making about false belief task performance.
Okay, last question, and then I'll call it off. And that is, this is the 75th anniversary of the Turing test. And there are some questions in connection with that and things like notions like theory of mind, light, etc., that I would want to ask you. I mean, how much the idea behind the Turing test is that once you have a model that is completely indistinguishable from a real person in its performance to any real person, you've got a model for the underlying mechanism. Maybe it's not the model, but it's a model, right? Now, to what extent do you think that that's true of LLMs?
To what extent do I think LLMs are indistinguishable, or to what extent do I think
both
that
questions? Are they indistinguishable? Okay. And is it does that mean that they really have passed the Turing test with their wherewithal?
I mean, I think Cameron Jones is here, who can probably speak to the actual empirical data
Cameron,
better.
I was hoping you would pop in.
But yeah, I mean, I know Cameron has a lot of great work that's come out recently showing that in a specific experimental setting, right? So like a short written sort of chat-like interaction with various LLMs, that LLMs prompted the right way can fool humans into saying that they think they're human. Obviously, I know there are questions about whether that means the LLM itself is passing the test, whether that's the right conditions for the test. My understanding is that it does match pretty well the initial conditions that Turing laid out. I don't think there's obviously all sorts of things that predict, that lead people to imbue a system with human-like properties. you know, I showed the Heidel and Simmer animation at the very beginning, right? We see a two-dimensional shape moving around on a screen. We imbue it with a narrative. I think there are lots of things other than the right generative mechanisms that lead to behavior that would lead you to think that something is intelligent in the way that a human is cognitively present and so on. So I think my sense is that they are hard to distinguish right now in these experimental settings. I don't think that entails that they are indistinguishable for the right reasons, which is why I think that this kind of like systematic studying of whether they are robust to all these different manipulations and so on is kind of the right approach.
Okay, thank you very much. We give you your run for your money, and you've given us the same. And I hope you'll drop in on some of the other seminars. And Cameron, I hope you'll be more vocal as a passive audience member in future sessions. Thank you very much.
Thanks so much for the invitation.